Welcome to my demonstration video for the COMP3004 elevator simulation. Right now you can see I have Qt Creator open in the VirtualBox VM, and I'll be demoing a couple scenarios for viewing. I'll go over to the build menu here, and I will just clean the project, and then I will rebuild it here so we have a fresh build. If I just jump in the edit section quick while it's building, you can see I have the variety of headers and then source files here for the different components of the elevator, such things like the simulation controller, the elevator control system, the elevators, all various systems there. Also have the main window, which has a large amount of slots and everything connected. And that is most of the code there. And if I just go to the UI, we can look at that quick while it's still building. I have a simple sort of page here for the setup, and I've designed it as such where we can input variable numbers of elevators, floors, and passengers, and then we can activate whether a certain safety event is going to occur here. I've made it so that events like the fire alarm and power outage are specified at a certain time. Our build has just completed there. Clock skew is whatever. If I can go back to the page here, just talking about it, I guess I can run it and then we'll look at the page. So on the page here, we have the safety events, as I was saying, and we specify them at a certain time. Yet some of the other safety events, like the help button and possible overloads, will occur in the actual actions of the elevator. So we don't necessarily need to pre-program those in here. We do those in the passenger actions and specifying like their weight, for example. So we will begin with one of my scenarios here. All of them have been designed with that some amount of floors and 2 elevators, 3 passengers in mind. So if I get my 3 passengers and I just look at I have a file over on my second monitor with the specifications for each scenario. So I'll go to 3 floors for the first one. And then you see below I have the windows for passenger action. So I'm just copy pasting in what certain passengers are expected to do at one time. So it'll specify their initial floor, the weight they carry with them. So it could either be like the person's weight or added objects, whatever it is. It's just some default integer value. Could be representing kilograms or whatever. It's just some generic weight unit. And then we will specify the actions a passenger takes down here. So at the certain time step that it'll occur, what their action that they're going to take is. So it's pressing up, pressing help, etc. Those kind of actions. And then associated with pressing an elevator button to go in a certain direction, you also have to specify a destination. So I will just add in the other 2 passengers behavior. It's just a JSON format here. So I have a library included in the build of this project. I found a library that's often used for JSON parsing in C++, and then just imported that and used that to parse out the actions in a standardized way. So when I hit start here, you'll see that it goes over to another window. It's currently going through the different time steps. I can pause it quick so we can delay that timing for the current time being. We could either stop it and then reset the simulation, or we could exit the page again. But just for now, I'm going to talk about some of the different things. So this is mainly logging for the purpose of an admin viewing it, right? It's saying the simulation has started with these parameters up here. So 7 floors, 2 elevators, 3 passengers. And then it specifies the actions that passengers are planning to take based on what we parsed out and the time step at which it occurs. And then the different facts about it. So then we say the simulation is going to start, and this just sort of helps. You'll see it again reflected in the actual system steps as we're going through it. So at event time 1, passenger 1 will press up with the destination 4 in mind. So we can see here time step 0. This is not the first step. This is sort of like the initial state of everything. We can see the passenger starts on floor 2, passenger 2 starts on floor 6, and passenger 3 is on floor 4. And this is our system report. So in each time step, this is sort of our report of where elevators are, where passengers are, and what's happening with them, as well as the elevator control system under normal operation here. So we can see all of our elevators start idle at floor 1 and come to pick up a passenger depending on where they are. Right. So at time step 1, we can see here now passenger 1 has pressed the up button on floor 2. Floor 2, the button illuminates on that floor, and then the elevator control system decides to send elevator 2 to that floor request. The elevator system itself is using an opportunistic strategy based on looking for any. First of all, it looks for the first elevator that is idle and available to take requests, and that is a potential candidate for the best elevator to assign to the role. So it'll always assign a new idle elevator to different passenger requests. If none are available and idle, then it will instead assign the closest elevator to the passenger's request, going in the correct direction to come and pick them up and continue to travel. And if it can't find a ideal elevator for this passenger's travel, then it simply adds it to some default first available elevator. So in this case, that would also be elevator 0, but if elevator 0 was unavailable, then it might assign it to elevator 1. And elevator IDs are just using 0-based indexing because that is easiest, and floors were using 1-based indexing as that makes the most sense in a building sort of system. So we can see in the system report for time step 1, passenger is on floor 2 and now wants to go to floor 4 with the destination. Elevator 0 has started moving, the direction is up, and its current floor is 2. So after getting the request in the previous, in this time step here, it then moved up a floor, and the sequence of actions we take per time step are that elevators will check if they're at a destination, collect any passengers, and then we'll move. I perform a lot of these actions all in a single time step, as it just makes sense that one time step is one opportunity for an elevator to move, and we can suppose that all of these actions take a certain amount of time allotted to open doors, close doors, collect passengers, but it's all modeled as one time step just for ease of system maintainability and how we travel through time. So if we can see time step here 2 now, the elevator arrives at our destination, it rings the bell, it opens the door, the passenger enters, inputs their request, the elevator now adds that to its request list, the floor button turns off, the elevator rings the bell again, closes doors, and begins moving. And again, we can see the report of all the different floors. I'm going to resume the simulation here, and then we can just see different passenger actions handled. You've seen the major things occurring, so now we can skip through it. The console here jumps down to the bottom every time, so once we get to the end, once the simulation runs to completion, we'll just check out some of the actions a little sooner after that, and then talk about some of the different features there. So it'll be just a minute here for it to get to the end. I believe it finishes the next time step. Yeah. So now the simulation has stopped. You can see none of the buttons are available, and we can either reset or exit. We look here, the system is operating normally. All passengers have arrived at their final destination. Passenger one went up a certain amount of floors and then came back down. All looks good. The elevators are now idle at their final locations. And if we jump back to the top here, somewhere in there, we can just start looking at the different actions that are occurring at time steps. So time step 2, we looked at the elevator arrives, collects the passenger, reports what's happening. Time step 3, elevators are just moving, nothing is really occurring during that time step. Time step 4, passenger 2 makes a request to go down, so an elevator has to be routed to come and collect them. And passenger 1 has arrived at the floor they requested, floor 2, and now exits the elevator. Floor button remains illuminated. So all these sequence of actions just sort of flow through it. I will scroll through it slowly if you want to pause and look at them, but I don't want to go too much through them for too much more time. As you can see, it's just operating, moving the elevators floor by floor, letting passengers on and off where they are. And this is just a scenario to show that All the passengers are moving independently here, so at no point are two of them on the same elevator, and also passenger one makes a request to go up and then also come back down, which can be handled by the system, even though in the middle of that, elevator 0 got reassigned to passenger three's request here, and then again a new elevator will be assigned to passenger one's request when they make their second request. I believe that's down here. Yes. Passenger 1 makes their request again, and then elevator 0 gets assigned as the correct elevator to handle that request while the others are performing other actions again. So that's good. I'm going to reset here. As you can see, it just keeps all the different all the different situations here, and then lets you reassign the scenario just in the window itself. So the second scenario here has an extra floor. And then I will copy over the passenger behavior quickly. Uh, the passengers get assigned IDs that are based on a static variable in the passenger class. So you'll note when we start the next simulation, they'll be called passengers 4, 5, and 6. That's fine. It doesn't really affect anything. Just a new name for the different passengers, which doesn't necessarily reflect the UI display, but it's just assigning unique IDs to them as they get destroyed and recreated throughout the simulation. So we start here with our passengers in this new scenario. We get their initial actions. I'm going to pause it quick just so we can look at them. We get the different actions, and this is a scenario where I can't remember off the top of my head. I have it written down here. So passenger 1 or passenger 3 joins passenger 1 here on their trips as they're going down. So I will let this run to completion, and then we can talk about the different actions quick that go on through it. Again, for the most part, this is just a normal scenario, so it's just elevators moving around, picking up passengers, delivering them to their destinations, and the added constraint of 2 of the passengers will join on the same elevator, as that has been determined to be the most effective travel route for this specific scenario. So it's finished up. It's finished up here. We can see elevators have gone idle again. Passengers have all made it to their final destinations. And we are waiting to perform other simulations after that. So we can just look here at event time 1, passenger 4 will press up, or passenger 1, sorry, presses up to go, or I guess passenger 1/4 will press up to go to destination 5. As we can see here, passenger 1 presses up. The elevator is currently on that floor, and we'll collect them immediately. We start moving. The system report here shows that passenger 1 is in elevator 0 with destination 5. The elevator 0 is currently moving up at floor 2. Passenger 5 is going to press the down button on floor 5. So now elevator 1 gets assigned that request, as it's the idle elevator right now, and with our opportunistic strategy, that's the best one available for this passenger's request. And then we can see we just update, move new passengers in elevators or waiting, and elevators now moving in different directions. Time step 3, passenger 6 here, so our third passenger, presses the up button on floor 4, and it remains illuminated, and the elevator control system deems elevator 0 to be the best for this request, as it is on the way of the direction it's already going, and passenger 4 intends to go in the direction that the elevator is currently heading, which is up. So that request aligns well with its predetermined route of travel. So we can see we have the updated state. It moves there. The elevator has arrived at floor 4, collects the next passenger. Passenger inputs their request, and it begins moving, and the elevators begin moving on their situation. So now we can see passenger 4 and 6 are in the same elevator together with different destinations, and the elevator will continue moving in its given directions. Elevator 1 here will go and collect passenger 5 at some point. So now elevator 0 or 5 has arrived at the floor and is dropping off passenger 4 at the floor. And then we can see that the elevator system just continues moving and updating as it needs. We now no longer see passenger 4 on the elevator. They've left. passenger 5 still waiting, and 6 in the elevator. So we'll just skip through a few more steps. It continues moving on with the different steps. If you would like, you may pause and have a look. I'm just going to skip through most of them, and that was most of the work there. So eventually, elevator 1 will come and collect the passenger, pick them up, and they'll get dropped off at the final floor. Everybody's at their final destinations, and we've returned to an idle state. All right, I'm just going to click 0 here, or exit, to restart the simulation, just so we get passenger names again before it gets too confusing and I lose track. We will set up the next scenario. The next scenario is what happens in the case of fire or power outage events. They have fairly similar outcomes, so I will program that scenario in quick: 2 elevators, 3 passengers. And then we also want to activate a safety event, fire alarm or power outage. Either one is the same, so we'll just do fire alarm here. It just depends sort of what the building's response would be necessarily to it, but the elevator system will have the same response of routing passengers to a safe floor, depending on when the safety event occurs. I've sort of hard-coded in the system that the safety floor is floor 1 for now. It could be set up for some variable thing, but for the sake of simulation, it is fine as is. And then the time step for the safety event is 12 here. So we'll start this up and let it run to completion, and then talk about the events that occur. I will mostly skip over what is happening with the passengers and their different actions for the most part at the beginning, as that's we've already covered that in the previous scenarios. It's not too important here. And then we will simply just talk about sort of what happens when the safety event actually occurs here, which we can see time step 9, a lot's happening there. We will soon get to the alarms. I believe I saw them quick there. Simulation should be finishing up in not too long, and then we will get to see the end state. Okay, so it's finished here, time step 11. We can see in the events above, this is the overall plan for the simulation. Elevators begin getting requests, start moving around as they need. Let's move down. We'll move to time step 11 or 12, I believe that is the one where we call the safety event. That's the most important. At one point, I believe one of these passengers, the simulation is designed in a way where one of the passengers, I think passenger 2, arrives at their, or no, sorry, I don't think it's passenger 2. I believe it's passenger 1 has completed their trip and just arrives at floor 6 and will no longer be involved in this sort of safety scenario directly with the elevators. They've completed their trip. They're going to their apartment or whatever it may be, and then the fire alarm rings after that. So they should be instructed to use the stairs, but they aren't directly involved with the elevator system anymore. So the elevator is currently collecting all of its passengers here. We see that passenger 3 is entering the elevator, and all the inputs are occurring as we expect. So we can just check here. Passenger 1 is on floor 6. Passenger 2 and 3 are both on separate elevators with different destinations here. And we go for a couple of other time steps. We look at the report for time step 11. So, here it is. So passenger 1 is on floor 6 with destination 4 in mind. So they've come up with a second action here, or no, sorry, this is their first action, I believe, so I got that wrong earlier. Passenger 3 completes their travel to floor 6, and now passenger 1 and passenger 2 have made a request, and I guess earlier passenger 1's request was deemed for elevator 0, so we can see at time step 12 here, the way that the simulation tracks behavior is it checks for any passenger interaction first, and then it updates the elevator movement, and then it checks for any safety conditions that may arise. So unfortunate for passenger 1, they get on their elevator, they request floor 4, elevator 0 begins to complete their request, and then just as they got on and began their travel, the fire alarm was pulled at some point, and now the safety system is triggering the fire alarm and activating any response protocols. And then the elevator system gets notified of this and begins handling the different scenarios. So all elevators will display their fire alarm message, and that they're being rerouted to floor 1. So unfortunate for passengers, you may have wanted to go elsewhere, but you now are being safely evacuated from the building. And that will happen here. So we can see that. And same happens for elevator 1. Despite nobody being on the elevator, it's still going to be routed to the floor here. So currently in the report, it says nothing is moving, which is it's fine, reasonable, because the updates for the system occur in the following time steps. So they get notified of the event here and then make the decision in the next time step how to handle it. We will see there the update. Elevator 0 and 1 both move. The system reports that passenger 1 and 2 are now in elevator 0 with the same destination, floor 1, and passenger 3 is on floor 3. They're not in any elevator, and they're prompted to leave on their own through the stairs or something. And now we can see that both elevators are currently moving down, heading to the safe floor. If we head down a few time steps, elevator 1 arrives at the safe floor first, and will stop there. Same with eventually elevator 0 arrives at the bottom floor and passenger 1 and 2 are prompted to exit. And the simulation ends with passenger 1 and 2 exiting on the safe floor, and passenger 3 should have exited via the stairs, but that's not the scope of this simulation. Okay, I will reset for the final scenario that we have here. This one involves a variety of different safety conditions that don't necessarily cause a complete breakdown necessarily of the system. We have 8 floors here. And the way I've modeled it again is that the help scenarios here only occur for these help scenarios, such as pressing help or holding the doors and buttons, occur within the passenger's action window. So it's not programming it in outside via those help boxes. If I can select this bottom one, that should be all the passengers' actions in now. You can see that they have their weight attributes now. That'll come into effect as this scenario will show a lot of the different actions all at the same time. This will be help. This will be in a help scenario, as well as pressing the open and closing on the door, and it will also model an overload scenario with 2 of the other passengers. So we can also check here. This is time step 4. Passenger 1 will press the help. The code variable here indicates what sort of help event is going to occur for this passenger. And we're just taking this into the simulation from outside so we know what scenario to model. A 0 in this case would be a simple help scenario where the passenger contacts building safety responds, and they sort out their issue briefly. So it's modeled in a single time step. No events necessarily occur that's bad. Whereas if we use code 1 or code 2, we'll show code 2 here, those are characteristic of one of the 2 participants in this conversation being unresponsive. I believe 1 is a passenger not responding when an operator connects, and 2 is for an operator being unresponsive to a passenger. And what happens in that case is the elevator should be rerouted to a safe floor, place a call to 911, those sort of actions. I added the condition for routing it to a safe floor. It wasn't specified in the design, but I thought that would be a reasonable course of action to take in the event that somebody has an emergency on an elevator. And this will override the behavior of any passenger currently on the elevator. So if you were on an elevator with a passenger who went unconscious, or if the safety operator did not respond to a help request, unfortunately, everybody on that elevator is now routed to the safe floor, despite if you wanted to go somewhere else. And your future trips are canceled, since likely in that scenario, you will have to undergo some form of debrief with the building operators and whatnot, the police maybe. So your trips in the future are unfortunately canceled for the time being. So we'll start up the simulation here. It'll show the different actions that we are about to process at the top here, and we'll let it to run to completion, and then we'll check out the different parts that activate during this simulation here. Shouldn't be too much longer. I don't remember the exact amount of time this takes, but it shouldn't be too much longer. I believe we quickly saw some of the overload behavior happening there, and we will just continue waiting. I believe it has finished up now. Yes. Perfect. So I think I forgot to mention in the previous scenario, but elevator control system here is handling safety condition. It displayed the same for fire. If it was a condition that required rerouting and potentially taking elevators out of order, then it's something that is a notable safety condition. But if it was just a passenger pressing the help button and chatting with the operator, everything goes smoothly, then oftentimes that doesn't really require the elevator system wide going into safety mode. Right, so it begins relatively standardly. Elevators are at their current spaces. Passengers have requests that they will make, and it goes through, begins picking up passengers, as we have often seen before. We'll skip to the notable part here, where at time step 4, or sorry, I missed a time step here. So time step 2 is one of the notable ones that happens. This is where the passenger is pressing the open and close door buttons to override the default behavior of the doors. You can imagine in the simulation that the doors have their default 10-second closing window, for example, and we're just modeling that in a single time step, as it doesn't make sense to delay the movement of elevators too much and just have them each move one floor at one time step potentially. So we can see here elevator 0 arrives at the destination, passenger 4 is entering the elevator, makes their request, and then passenger 4 is also pressing hold for the elevator. Perhaps they thought somebody was in the hall waiting behind them, or they just needed more time to bring their belongings into the elevator, so they've holded it. They've held the door. The elevator 0 has had the timer overridden and is keeping the door open, and then passenger 4 got everything on and is now a little impatient and presses to close the door again, so it's overriding the door closing, and then we close the doors here. In the code itself, I implemented the door sensors and whether they're blocked or not using a sensor class that sort of right now just acts on a random number. So I believe it was 75% of the time the door closes fine, and 25% it'll have an error and open the door again. That we can check out the code after that. Whether it happens in the simulation or not doesn't really affect the overall train of events that happens, the sequence. It simply just adds another open and try again to close the doors during the same time step. So that sort of thing has been modeled with how it might affect the travel of the elevator on that macro or the micro scale of the one time step there. So we can continue with the movement of that elevator here and go to time step 4, which was the important one again. Elevator 0 notes that the help button was pressed. It's connecting to an operator. This was where passenger 1 in the elevator, or passenger 4 here, pressed the help button in that elevator. And we connect them to an operator, but the passenger attempts to chat with safety, and the safety is unresponsive. So the safety operator unresponsive, and the 911 call has been placed. The elevator control system notes something has happened since the call has been placed and has to respond to an unresponsive safety event, rerouting affected passengers on elevator 0 to floor 1, which is our designated safety floor, and the elevator begins moving in its direction. So the elevator over the next few time steps moves. Passenger 5 has pressed the floor button on 1. They want to go up. And we can see here elevator 1 deemed elevator 1 good for the request. This doesn't affect the ongoing safety condition in elevator 0. The other elevators can still remain operational in the building, but we just simply cordon off elevator 0. It's no longer in service. Police will need to deal with this, but there's not necessarily reason for it to take down the operation of the entire system. So elevators arrive, drop off, pick up passengers as needed. We can see here, I believe in the next time step. Yeah, the next time step here, elevator 0 arrives at the floor. The passenger who had a safety event crisis has now been let off at floor 1, or perhaps held at floor 1 until police arrives and helps them with the situation. Elevator 1 continues with the different requests that it has in the system. It will, at some point, it arrives at floor 4, which is the request made by passenger passenger 6, so passenger 6 was at floor 4 and requested to go up, so now elevator 1 has come to collect them. We see that in passenger 6 entering the elevator, suddenly they have exceeded the maximum weight. Perhaps passenger 1 wanted to bring some heavy items with them, for whatever reason may be, and unfortunately the elevator detected an overload and has said we cannot move for safety reasons right now. Please decrease the weight, leave some items behind. So perhaps the participants then leave some items behind for a second trip and the elevator then begins moving to drop them off here. The elevator control system is still in safety mode as it's handling what happened to the first elevator. But for the other passengers, they simply continue on their travel and they arrive at their correct floors. So we have passenger 4 waiting at floor 1, and the other passengers completed their travels. Maybe they will need to make another travel now to collect their extra belongings that they left behind. But that's the content for the simulation here for now. Right, I will exit here and I will just quickly jump to the door sensor code here. So just the door sensor defined here. Just to show you what it's doing this is just a random number generator I found on the C++ documentation. It just generates a number with a distribution 7.5, so 75% of the time it'll return true or false. We do this right here, just some code here because it doesn't comments to myself as it didn't seem to be activating too frequently, but it does activate. I've seen it in different simulations, but it doesn't happen all the time. It's just sort of a random occurrence since I didn't think it was necessarily all that valid to program into the system as a whole to occur at a specific time step. It can just happen at random and be handled by default. So I believe if we check the elevator quickly, you'll see some code here for arriving at the floors, checking the weight, etc. If I check the closed door procedure here, the important one, we can see here we're tracking the number of failures that occur when trying to close the door. So we loop while the door is attempting to close. If the sensor is blocked, then we simply retry. If we hit 5 failures, then it will display a warning message for clearing, and that's sort of the last kind of safety event that could occur. But the way I've designed it, it doesn't occur very frequently. It would be rather strange that it would happen something like 5 times in a row and have to display a discrete warning to the passengers, but it could happen and has been modeled in the simulation here. I believe that concludes the description of my 4 scenarios, and please feel free to pause at different time steps during it to check out some of the output in more detail if you like. I know there's a lot printing, so don't feel too pressured in that case. Thank you.